with the goal of circular economy implementation to the hop-growing sector. The European LIFE project BioTop endorses the use of alternative bioplastic PLA twine instead of polypropylene twine, so the biomass after harvest became a valuable feedstock resource for compost, pulp fiber, reinforcing filler additives and biocomposite compounds, through the most extended manufacturing technologies, for example, extrusion compounding, injection molding and hot pulp pressing. With the goal of reducing plastic pollution from the hop production, besides replacing polypropylene twine with PLA twine, BioTop will introduce circular economy to hop sector not only with possibility of proper composting of hop biomass after harvest, allowing to return biomass to the agricultural fields, but also with extraction of fibers out of hop biomass, which will be used as reinforcement in PLA pots for vegetable and hop seedlings production, being 100% compostable. Processing of hop residuals that are stalks intertwined with biodegradable twines and which stay as a byproduct in the hop cones production at the Slovenian Institute of Hop Research and Brewing is handled by Zelfo Technology GmbH. This involves reduction where necessary and preconditioning of the fiber mass before actual fiber processing begins. Once the fiber is of the correct size and consistency, it is fed into the core processor, which is the key technological part of the system. Within the core processor, the fibers are reduced and restructured. As in the BioTop project, there are two separate streams required for two separate purposes. One, plastics, two, pulp molding products. There are two separate processing regimes involving differing machine configurations and output speeds. A potential secondary income stream has been identified during the first processing session in 2019. This involves liquid or slurry-type extracts, which are removed at a designated point during the fiber processing. Extracts' properties vary based on plant sources and seasonal conditions. There are sufficient common factors which will allow the basic future of the extract to be determined. Currently, the fibers are dried to a standard agrocrop dryness level after processing to halt biodegradation, and in the case of the plastics end use, to ease feeding into the compounding system. Transportation is also made easier by drying the fibers before shipping. Within the LIFE BioTop project, one way of the hop fibers is directly to partner Techno Packaging in Spain for biocomposite production.
Techno Packaging is a technology-based company located in Zaragoza, Spain. The company is specialized in the production of advanced biocomposites and blends, including the development of plastic parts and packaging with high-quality surfaces and smart functional requirements.
During BioTop project, Techno Packaging is in charge of the production of hop fiber reinforced composites. BioTop materials will be used for the injection of planting pots, and it will also serve as base material for the replication activities. These replication activities, as an example, are the injection of automotive component parts or the production of protective film for agricultural purposes. So let's have a look. At Techno Packaging facilities, we use a semi-industrial extrusion compounding machine for the production of biopolymers and composite materials. The extrusion compounding system has several parts, including the feeders and the extrusion screw, which in this BioTop project has been modified and optimized for the production of biopolymers using hop fibers and PLA-based commercial biopolymers.
The specific density of the fiber is calculated to control the percentage dosage added to the compound. Once the densities of the ingredients, PLA and fibers, are calculated, they are incorporated using two different feeders. PLA is added using the main feeder on the top side of the machine, and the fibers are incorporated into the blend using the secondary feeder located on the lower part of the machine. Both flows of material are then mixed into the main screw, which is heated up to a temperature to ensure the melting of the base polymer without damaging the fibers. The mix of materials moves forward by the rotation of the screw, and once it reaches the end, the hop fiber-based composite passes through the cylindrical die, obtaining a filament that needs to be cooled down. The cooling down phase consists of a water bath where its temperature is decreased before converting the filament into pellets. After the cooling down in the water bath, the filament is pelletized and stored in dry conditions, waiting for the injection process to happen. To avoid the degradation of the pellets due to the absorption of water during the cooling down process, a final drying step is required. For that purpose, the biocomposite pellets are kept at least for 84 hours in an oven and then stored in a dry place before being sent to Tecos, who will use them to produce planting pots for the next hop growing season. To test the mechanical properties of the biocomposite from Biotop project, testing under tension and flexural conditions are performed. From this test, a complete mechanical characterization of the blends is obtained, and the best performing materials, according to the final end-user requirements, is chosen to be upscaled in larger batches.
Within the Live Biotop project, we send the hop biocomposite to Tecos in Celje, where the new biot hop material is transformed into new planting pots.
Tecos is a technological center founded in 1992 on the initiative of Slovenian mold makers, and we are situated in city Celje in eastern part of Slovenia, and our key focus areas are the advanced manufacturing technologies, processing of bioplastic materials, implementation of circular economy practice, and also development of production systems coupled with Industry 4.0 perspectives. We are a proud member of Live Biotop project. In this project, we are in particular in charge for a demonstration pilot of injected molded planting pots like this, and these pots are entirely made of new biocomposite materials constituted from wasted hop fibers and biopolymer, also called PLA, which is a short abbreviation for polylactic acid. And these pots are planned to be certified for industrial biocompostable products, and as such they are presenting more sustainable solutions for the horticulture or gardening sector. Newly developed composite pellets from wasted hop fibers and PLA biopolymer received from Spanish SME Technopackaging are firstly dried in industrial dryers to keep the moisture level below the 0.02%. The drying process involves 6 hours at 60 degrees Celsius.
By injection molding process, we can produce high amount of products in very short amount of time. So it's very rational and efficient process for a mass production. Before the production stage, the newly constructed mold is installed on the injection molding machine. The processing parameters are then adjusted to the technical demands of the material on the control panel by the machine operator. The temperature profiles, injection speed, pressure, holding time and other processing parameters are entered according to the predetermined optimized values. The temperature of the mold is set to the required values on the tempering unit that is connected to the injection machine. The biocomposite dried pellets are then transferred into the injection molding machine via a hopper where the material is melted by heat and shear. The molted bioplastic is then injected into the mold where it cools and solidifies into the final part of the planting pot. When the mold is opened, an injection mechanism is used to push the final planting pot out of the mold.
The produced series of planting pots are carefully packed and shipped to the Slovenian Institute of Hop Research and Brewing, where they are used for the production of hop seedlings. The planting pots in the folded sequence are placed in a potting machine, which fills them with a substrate. The machine makes holes into the substrate to enable enough space for rooted hop seedling. The pots with the substrate are further transported along the planting line, where workers manually insert the rooted seedlings into the pots. The planted pots are placed in transport platforms, which are then removed to the greenhouse. All planted hop plants are managed for another 3 to 5 months, depending on the planting date. These hop plants remain in pots and are cared for until being planted in a hop garden, which can also be over the dormancy time in the next spring. At the end of their lifetime, the pots are considered to be disposed in collection bins for organic waste. They are 100% biodegradable and 100% industrial compostable, which means that the bioeconomy circle on hop farms is completed. Besides planting pots, there were also other products made within the project. These are, for example, harvesting machine fingers, buttons, thermoform trays for campers, playing bricks, phone holder, packaging for creams, and shoe horn. All the products are 100% biodegradable and 100% compostable. So with hop biomass, taken nutrients from the soil can be returned back to the agricultural land in a form of compost, and the circle of circular economy is closed. This video was made with the contribution of the EU LIFE program.